Welcome back to part 2. Let me zoom in here a little bit. We're going to talk about the nonlinear function and the average rate of change. So obviously you can't just pull a point. It doesn't have the same rate at which it's changing every place. So what you're really finding the slope of, if I want this line right here, you're actually finding the slope of what's called the secant line. So if you remember that from your geometry class. And the secant line is very similar to this slope, right? Let me just pick some points here. If I pick this top point and this point, and if I want to, I'm going to turn the paper a little bit because I draw better. Okay, I'm really finding the slope of that line. And that line, if this was x1 and this is x2, then if I plug those values, that x into my function, I will get that y value, but I'm going to call that f at x1 because that's where I would be plugging it in, right? I would be plugging in that x1 and I would get the y value. Or here, if I am evaluating it at x2, I would be evaluating the function at x2 and I would get that value. Now to get the slope of the secant line, you use the same concept as you used the slope over here. I'm going to take the difference between the y's and the difference between the x's. So the equation becomes the function for x sub 2, that y value, minus the function value at the first x, and I'm going to divide that by the change in x's as well. So I also have x sub 2 minus x1. And look how similar that is. It's the same concept. So don't worry about having to memorize a new formula. It's the same principle. Okay? Let's just point out that this one is not constant. Okay, because it's changing depending upon where the curve is. All right, so it changes depending on the points and the interval that you're using. It's going to be changing it. What we did earlier, it's going to be increasing faster in some parts or decreasing very slowly, or it could be decreasing very, very fast, have a very, very fast drop. All right, so let's try an example. I'd like you to find the average rate of change for this graph on this interval. Now, I'm going to pause for a minute and I'm going to set this up and I'm going to get a visual for you. All right, if you look at this graph, you see how it is. All right, so right here it's decreasing, it came in, it's increasing, decreasing, and increasing again. But I'm only interested on this graph on the interval from -5 to -3. -5 is out here. There's -3. So you can tell it's coming in, and that part of the graph is very, very steep, and it's a little bit tilted towards the left, so it's probably a negative slope. But we don't know. The tangent line would be a negative, or secant line would be a negative. So let's go ahead and evaluate this function. If we want to find the average rate of change, remember our formula, we are going to take the function value at the second part of the interval, which is -3, the greater part of the interval, minus -5, the function at -5, and then on the denominator we have the greater number, which is -3, minus the -5. Okay? Now, to evaluate this, if I plug in -3 into the function, all right, so I've got -3 to the 4th minus 6 -3 squared plus 4 times -3 minus the function value at -5, so that's going to be -5 to the 4th minus 6 times -5 squared plus 4 times -5, all divided by, I can look at this and tell that that's going to be 2. And now I can do all of this algebra, and I can determine that this right here is going to be 15. This is minus 455, all divided by 2. It's going to give me a negative 220 average rate of change. Does that make sense? Yes, it does, from our estimation. Now, I also want to point out that I wrote out the function value so that I could calculate that. But I want you to think about how I could very quickly evaluate that function at -3. If I have a calculator available, that becomes very easy, right? I would encourage you to write it out a couple times just so that you remind yourself what you're doing. And you remind yourself the direction, okay? So that you know that you're plugging in the -3 and evaluating it at -3 first before you do the -5. It's just like the slope, okay? You've got to be consistent. If you're going to do this point first, then you need to do that point on the bottom, okay? And you need to go in the same direction. All right, when you come to class, we will do lesson 1.4. If you want to, you can get started on it. It's on the back of the 1.3 lesson that we did, and I will see you then. Thank you.